This video shows how to set up the HolidayCoro Long Range Smart 16 version 1 item code 951-72 long range receiver. Now, this video is focused on non-xLights applications. So if you're using xLights, please see our xLights specific application as that has auto configuration. This is for any applications such as Madrix, DMX consoles, or Lightorama software that set up in a normal traditional universe channel arrangement. All right, so let's first kind of look at our board here. A couple things. First, over here we have our dip switch position. That sets our address of our receiver. In this particular case, it's down, which is 0. Here's our input cable, output. These have daisy chaining. The red lights down here indicate that the fuse is not blown. There is a green light which is right next to that, so it's right to the right of my finger there. It will light up green when we've programmed the output. We also have up here 4 LEDs which will tell you if there's data being received. Over on the right we do have a blue light indicating there's power, and then finally we do have a button here for test mode if you're trying to test your receiver. Now, let's give you kind of a lay of the land of how we've got this set up so you know what the test environment is. Okay. Here's our output device. This is a HinksPix Pro version 2. This is applying to V1, V2, and V3 CPUs. And in this particular case, this board right here is our long range expansion board, item number 951-31. And it's hooked up to ports 1 through 16 right here. And that means that this far left jack is ports 1 through 4, then 5 through 8, 9 through 12, 13 through 16. Now that'll become relevant later because this cable then is the data cable, the orange cable coming out. And also we do have an SPI board in this particular controller, but this video is not about configuration of that device. This applies only to the long range. All right, so our data cable is orange, it's coming out, and we're going to come through the bottom of the box over to our receiver, and it plugs in this left jack. That left jack again then goes to, as you can see here, line in. You'll notice this says line out, line in. So our data is coming in here. All right, so now we know what we have. We're going to go ahead and switch over to our HinksPix Pro controller. Now, this video does not cover the process of setting up and configuring your HinksPix Pro to access via the Ethernet network. It should also be noted that all long-range jacks are red in color. So, if you have a jack here, you'll see that they are all red. We should only ever connect red things to other red things. That indicates that they are long range. Compared to, let's say, these jacks on the right, which are black, which are Ethernet. All right, so got our controller. It's hooked up on the network, and nothing's really configured here. And this is our current setup in firmware. All right, now how we're configuring the controller is actually putting data into the port config right here, and the E131 ArtNet DDP is to DMX universes. Now, we do not support you setting that up directly. It can be done. These are really more of a read function if we're trying to confirm or look at some settings. The controller will do all the setup for you by going to this design tab. Now, first we do need an SD card, and if we go over here, we can see that the SD card is installed. The SD card is active and installed, and we do need an SD card in the controller to be able to save the configuration. It should be noted the micro SD card must be less than 32 gigs or 32 gigs. All right, so you can also save multiple designs, and in this case you can see we have some previous designs, and you can switch between those designs. So if you're doing a show or other types of things in different seasons or setups, you can save these settings and then just reload them really quickly. All right, so first thing we're going to do is we're just going to come over here and put a checkbox in long range. It's going to tell them, hey, we're using a long range. Now we're going to use long range, this long range board in this long range port output. Now how do I know that? Because if I come up to port config, I can see that it says ports 1 through 16 are long range ports. All right. You can also control intensity at a global level here for all the things connected to that. Now, we won't be configuring multiple long-range expansion boards or the SPI or the DMX output. So this is a straight DMX RS485. All right, so next thing we're going to do is come down here and say, hey, guess what? We're going to put cable 1 on the first jack. And the first jack is the far left jack. Remember, that's 1 through 4. And we're going to check that off and say it's active. Well, when we check that off, it now has long-range receivers attached to Cat5 cable 1. It knows that this Cat5 cable 1 on this long range right here is on ports 1 through 16. Great. Now we just have to set up our strings. So I'm going to add an extra couple strings just so we have extra room. You can also delete and add strings by clicking the green or red buttons here. So if you need to delete any, you can come in here after you've put them in and just delete them. All right. Now, for our setup, what we're going to be doing for this setup is we have output 1, and it is set up to seed pixels, these smaller ones. And we also are using output 7 here, and it is hooked up to traditional pixel nodes. All right, and you can see in this output, this is 1 down here and 7 is over here. It is a little hard to see, but this actually looks like it's already programmed. Okay, so let's go ahead and flip back over into xLights. And so what we're going to do is we're going to put output 1 long range seed pixels. All right, so then we'll put output 7 LR nodes. Okay, and here what we're going to do is we can put multiple universes. The controller will flip over at 510 channels because 170 pixels divided by 3, it's 510, and we do not use universe channels 511 or 512. It just skips them. So if you are putting in multiple pixels across multiple universes, you can enter them such as 510 and 510 and, oops, actually you'd need number 2 here, for example. All right, so if you do need to go to multiple universes and have more than 170 pixels, you can do that depending upon your CPU. All right, so in this particular setup, we're just going to say we have 150 channels or 50 pixels. Now you should note in some places we've got channels, in some places we have pixels. All right, so then we're going to say universe 2, we're going to put on 150 channels also. All right, so we've got what we need. We can actually do a sanity check by clicking here, and it says, hey, the string data is valid. All right, no errors. You haven't asked it to put more pixels than are possible or anything like that. So that's all good. So now what we need to do is we need to come down and tell the tool, hey, what kind of receiver do we have? Now, this specific receiver is a Smart 16. It's the version 1. So we're going to hit Smart SPI 16 ports, and you'll notice it has one board ID, and that applies to all of these. What really is happening in the background is we really have four output receivers daisy chained together. All right, now here are the physical ports on the board, and so we're just going to say 1. All right, so we have the seed pixel. So I'm going to click in this string field. It turns green, and I'm going to come up and select the appropriate string. So this is almost like a prop or a fixture you would set up. You would normally have in your application. So click over here, and then that maps them together. You may hear a beep on your computer, and then I'm going to click, actually I'm going to click 7 down here, and then I'm going to put that in there. All right, so what we're going to do is now we're going to go up here to perform a design check, and it says, hey, design check's okay, great, okay. And if we come down here, we can see that it's now put in a start pixel here and a start pixel here. Don't worry about any of that. We're just having it tell us, hey, we need to set the pixels in a certain place. We'll also see that it's populated the 150 channels here. So at this point, we're all good. We've checked the entire design and it looks good. So we could say LR16 SPI test 1. All right. And we're going to say save design. Design has been saved. And it says all good. We're good to go. All right. So now we have this file, and if I were to actually refresh the page, you can see it empties everything. And if we were to go down here and select that test we just did and say open, you can see everything that we've configured is all there for updating if you need to. All right. So what we're going to do is we're going to go over and load that, because this does not load it. This is essentially just a configuration tool. It only creates a file on the SD card that you must then load. So we're going to come over to miscellaneous settings, manage controller configurations, and we're going to now select that from our list, and it's right there, and we're going to say install. It will now say it's been installed. We need to reset. So we'll come over here to reset, and we are going to reboot the controller. Now, what's happening in the background is the controller is rebooting. Now, it's important to note that this receiver must be online and connected. Yeah, see here, we got the green light there, and we got a green light here and a green light there. So they are connected. So you'll notice there's no green lights up here. What's happened is at least one time when the controller boots up, you may see a message on the screen of the HinksPix that says LR config 16. What is happening is it's sending the data down to the receiver, and the receiver is saying, hey, guess what? I'm receiver 0 on this particular Cat5 output jack of the output long range. I need to control specific outputs, and then that's where it turns on this green light and this green light right here, and it's now ready to control those pixels. All right, so at this point, we should be ready to go. So let's go ahead and flip back over to our controller, and we'll wait for this controller to boot up, actually. All right, our controller has rebooted now. Now, let's just take a look at the configuration that has now been loaded into the controller. So we go to port config, and again, it's a reminder, this is not intended to be the method we configure the controller. So we're just going to look at our configuration. The first thing we notice is that these are on streams or ports. So in our Cat5 cable, we have 8 wires or 4 pairs of wires. And so what that means is this is port 1, port 2, port 3, port 4. Why does this matter? When we go to do a test internally within the controller, our outputs 1, 2, 3, 4 will be on this particular output or port 1. This one's going to be 5, 6, 7, 8. So this is actually port 2, and our setup was output 1, output 7. All right, you'll notice that we have 300 total channels that are consumed internally. If we come over here, we can see that the controller settings have been set to 150 channels on Universe 1 and 150 channels on Universe 2. So all this matches, everything looks good. So we're going to come over here to test outputs. We're going to test the port 1. Remember, this is outputs 1, 2, 3, 4. So I'm going to put a checkbox in here, and I'm just going to blink red. So if we turn on our camera and look at the actual output, we'll see that we have output 1, and they're blinking red. So exactly what we wanted. We'll notice that 7 doing nothing, which is exactly what should be doing. All right, so let's go back over, turn this off, and remember, this is on our second pair stream or port, and we're going to blink green. So if we turn on camera again, we can look here again, output 7, we're blinking green. All right, so we know at this point our controller is properly set up. Now, we may want to move up to the next level and now test our application. So I'm going to go ahead and bring in sACN view. Now, this could be any application. It could be Lightorama, it could be a console, it could be specialized software you use, it could be Madrix. Whatever you use, it's going to have 3 things. It's going to have a protocol, and that protocol can be up here. E131, or also referred to as sACN, ArtNet, or DDP. So usually it's going to be sACN, E131, or ArtNet. We're going to be testing with E131 today, and we're going to be doing it in a unicast fashion. All right, so let me go ahead and get my sACN viewer, which is a tool that's just a free tool you can use for testing sACN networks or E131. All right, I've got my sACN viewer up here, and we're just using the output function, and you can see here we have a transmit, and we're currently on universe 1, so we're using ratified. We're just going to go ahead and output all 512 channels on universe 1. And remember, universe 1 is tied to my output 1. I am unicasting to this IP address due to my network setup, and I've come over here to the fade range just so you can see that there's some operation going on, and I've just changed this fade rate. So you can see that it is changing from 0 to 255 in just an oscillating pattern, DMX channels 1 through 512. So let's take a look and see what we got here. So here again, we have output 1, and you can see we've got our flat fading 1 through 512. And of course, each one of these is 3 channels, and so they're fading equally. Now, I should also mention, it's maybe a little hard to see here, but if you look up here, see those flashing lights? See how they're flashing? That's telling you that you're receiving data on the 4 pairs of wires from the controller. Let's also see something interesting that's useful for troubleshooting. So let's turn that off, and we're just going to, while this is continuing to output, we're going to come over here to the status tab. And what we can see here is if we click on the auto live update, what we can see is that currently the controller is receiving on universe 1, it's received this many packets of data, and there are this many errors. And of course, we want the errors to be 0, but we can see that live data is being received from the console or device, in this case, sACN viewer, only on universe 1. So that tells us, hey, we are not receiving data over here on universe 2. We can see it was a little bit of test data, but nothing right now. All right, so let's go back over to sACN viewer, and this time what we're going to go is go ahead and stop this, and we're going to change it up to universe 2, and we're going to start. So first thing we're going to do is come over here, and what we can see is now we're no longer outputting data onto universe 1, but now we are receiving data on universe 2. You can see that number incrementing because I've got my auto live update. If we reset that, you can see. So let's go ahead and now look at it from the real world. So here we go. This is output 7, as you can see here. And they are, of course, well, let me get that to work here. 1 second here. Oh, actually, I think something has happened here. Let me check that. All right, here we have our data increasing, and that, of course, is again coming from sACN viewer here. And let's go ahead and take a look at the real world here, and you can see they are changing back and forth, and it is fully functional. All right. So that goes ahead and concludes this setup. If you ever have technical questions, feel free to reach out to us. Our address is holidaycoro.com/contact us.